there are a number of things we can choose to work on. These images are still in their linear form. I'm going to choose to work on taking care of the flat field errors. These errors cause a non-uniform background that produce gradients and other crazy things that we want to flatten and model out. And I'm going to choose to work on the luminance image first. As far as the color images are concerned, instead of modeling the backgrounds individually on each of these images, I'd like to combine them, as we'll do later, into a single color image and then work on it. Of course, the process that we're going to use is dynamic background extraction. And it's a wonderful tool, but there are some techniques for using this tool to make it very effective. And my philosophy for using DBE is to first look at an image and try to identify any symmetries, anything that is somewhat symmetric as far as your non-uniform gradient-like stuff. If there's just a glow here in the upper right and nothing in the lower left and so on, that's not the thing to look for. In this particular image, you can certainly see something that is symmetric. There's kind of, and I hope this comes across in the video, there's kind of a brightness here surrounding the galaxy. It is darker towards the edges radially, then it gets a bit brighter, and then it actually gets a little darker yet again. So there's a donut or an annulus in the middle of the field. I think the origin of this glow, by the way, are the city lights of Tucson, and they just don't get flat fielded out, and it depends on the given night and given data, how many clouds were passing through the field, that determines how egregious this particular kind of thing is. And so I want to take advantage of DBE's symmetry option to try to tackle that first, and then anything else that's left over will be easier accomplished, will be easier taken care of with smaller, much more directed samples, a smaller number of samples placed throughout the image. So let's load DBE first. I've identified what is symmetric. Sometimes you won't have anything symmetric. You got to go right to placing samples. But in this case, it's good to get rid of any of these large-scale structures, because if you commingle them with smaller local-scale things, it's a very complex thing to try to model. So any kind of simple things you can model out first and leave the other things, you'll find it'll do a much more effective job. I'm going to place points, perhaps starting here, and then working my way inward radially. But I need to set up some of the parameters. So let's click on the image and then set up some of the parameters. One of the things that might be surprising is I'm going to make the tolerance relatively high and aggressive. That's because I'm going to be sure, of course, not to click on any stars and not model anything that is even remotely important as far as the sky and background is concerned. So the galaxy is very well defined, and stars are not going to be harmed by this process. So I can be a bit more aggressive. If this field was filled with nebulosity, perhaps I would choose a smaller number for the tolerance. I know also, because these are large-scale structures and features and gradients, that a smoothing factor that is greater than the default would be something that is more effective here. So I'm raising this smoothing factor up a bit. And for my samples, I tend to make them as large as I can. So I'm going to increase this to a sample size of 30 pixels. This will make bigger squares when I click here on the image. So the first sample I'm going to place is going to be down in this area here, and this sample will serve to kind of characterize what is radially towards the outer part of this image. You'll notice here that there aren't any stars or anything in this picture, so that means it's probably just a fine sample point. And we're going to take advantage of the symmetries by saying that all of these regions of the chip at this radius should have approximately the same kind of sky values. So I just increase the number of sides of the polygon and make it something like a circle. Now the next sample I'll place somewhere in the glow to characterize this region, and of course the idea is that these should all be equal, so it's going to do its modeling job. You need to select things that are both in and out of your glows and your gradients. And once again, we'll do the axial bit. I'm going to choose or make one more sample here of what I think characterizes the glow, kind of maybe towards the inner part of the glow. And then again, as I noted earlier, there is kind of this turnover that's very close to the galaxy. It gets very, well, not very dark, but it gets darker near to the galaxy. So I'm going to click somewhere near the galaxy, maybe here, and do one more kind of control circle. Now, the galaxy is not really centered on my annulus or anything like that, so I'm going to shift this so that my circles better characterize the annulus, not necessarily the galaxy, although as it so happens, it looks like I am centering on the galaxy, but I'm really trying to take care of that annulus and make sure my circles are going around the annulus here. I'm clipping apparently the galaxy, but I think that's going to be okay. It's not going to be a big deal. So having created these samples, I can choose my correction method. In this case, of course, we're going to do division. I almost always do division when I'm talking about flat field errors and these kinds of problems. And then I think we should see what an image looks like. So we're going to get both the image and the model. Let me just show you what the model looks like. So here's the model, and at first glance it looks like a smooth gradient, although on my screen it's kind of quantized here. Mathematically I'm sure it's a smooth gradient, but it's being displayed in this kind of stepped grayscales. So we can, if we want to view it nice and smooth, we can come here under image, and sometimes I forget where it is. Yeah, here under the screen transfer function we can use the 24-bit STF, and that now makes it nice and smooth. So that looks like a reasonable representation, but what concerns me is I don't see a kind of a discrete drop-off in intensity of light as I get closer to the center. So I'm not sure this is going to be the final adjustment here. Right. So what we now have is a background which, away from the galaxy doesn't look too bad. But then as you get close to the galaxy, there is a turnover. It becomes quite dark. So one of the things that I like about using these symmetries, and this applies to any sample you can do this with, but it's especially powerful when you have these kind of symmetry geometries, or polygons, I guess, on your image, is you can make a fixed value and just adjust that fixed value to either make it brighter or dimmer in these regions. So you can adjust the model basically by hand. Now you have to be very gentle about it, but you can do it. So let me show you how that works. Now you'll remember that that was a little bit darker towards the galaxy. So what I'm going to do is look at this point, because it looked like it was far enough from the galaxy. It's probably this point that I need to adjust, at least at first. And I'm going to convert it to a fixed value so that now I can adjust the value, either making it bigger or smaller. Now I can tell you that the difference in brightness between something here and something here is very, very small. I mean, we're only talking about 1 or 2 counts. So in a space where we're normalized between 0 and 1, I talk about this earlier in a video, what is 1 or 2 counts? What does that represent? Well, in terms of significant digits, we're at least talking about the 4th place here. At least the 4th place, and then maybe we fiddle with the 5th and 6th place. But I know the 4th place is going to be a significant digit, and it'll certainly adjust, I think, the brightness that we see here when I make adjustments. So let's try, instead of 723, I'm going to try to go, I'm going to put 800. I'm going to do what I think is wrong, just to show you. So I'm going to do 800 here. I didn't hit 8, I hit some other thing because my microphone is in the way. 800. So I basically went up. We went from 723 to 800. I'm going to apply And that inner region will either be brighter or darker because of that adjustment. I think that got darker, not brighter. And what we wanted to have happen is to become a little bit brighter, and that would decrease the darkness that we had for that control point. So lowering this value for my image, and I think that I got to think about that. I don't know if it's always true, but it is certainly true here. It's usually true for me, is going to make that sample point brighter. So let's lower this one. Instead of 723, let's go with 680. And we still have a darkness here, but we also have one more sample point inside. And we can maybe use that inner sample point to get rid of this little bit of darkness. And then I think we'll have a reasonably adjusted field. Now, I note that I can almost see it might be overly correcting here, or maybe not correcting enough. I don't know. I got to think about that. It's very, very close. So let's give it another go. I'm going to make this one 700. And why don't we likewise try to make this one, if it's a similar value, yeah, we'll try 700 here as well. And let's see what we get. Not bad. So what we should do then is I am going to create a quick process here so we can save these settings, and then let's compare. So I'm going to close the dynamic background extraction tool. By the way, here's what the model looks like. Now you can see it's changed somewhat. It's still in this quantized version, but it's changed somewhat. Let's show the, there it is, right. So that's here and here. It's hard, it's still hard to see the drop off here, but there's a little bit of a darkness going on in the center. It's very, very subtle. So we went from, we'll do page down, we began here and we ended up here. So here's before and after. And I think, at least I hope this comes across in the video, that the large scale structures were reasonably taken care of. It's not perfect, but a second application of some careful and thoughtful control points, samples, will take care of the remaining issues in the image, and then we should have a really flattened image to work with going forward. Let me just blink a few more times to really convince myself that, oh, I shifted it. And I got to close this again. Ay caramba. Yes. Yeah, I think that that's fine. So now we'll just use DBE again with a small number of samples, or certainly a smaller number. I notice that there is a slight gradient. It's just a little bit brighter towards the top right than it is anywhere else. So some selected samples should help me take care of that. So again, we click on the image. We do, you know, I think 3 is probably good now. We still want a nice smooth result, so 0.6. Still want my 30 pixel samples. Why don't we do like, I don't know, 4 per row. We'll just scatter them around. There they are. And I'm just going to click on the samples. I'll move them away from the edge, make sure there are no bright stars or anything going on there. So I'm looking in this box here and just making sure that I have a little piece of sky which looks okay. I don't want to be anywhere near the galaxy. with my samples. So these samples look okay. I just don't want to be anywhere near there. I think I just made a sample. I don't want to make any extra. Looks fine. Okay, that one obviously needs to move. Now I'm doing this because my tolerance is a little bit high, and that's why I'm just making sure I'm avoiding stuff. If I had a lower, smaller tolerance, I wouldn't worry about this as much. I just don't want to introduce any local weirdness. And one more. That's fine. So that should do it. We want the correction type again to be division. And let's apply. Hopefully this will show something like a gradient. It does, from the top right going down. So, oops. So I'm hoping that this should show the correction that we hope or expect. So I'm going to, I'll save this process. So now I have two processes that were necessary, DBE processes necessary to fully take care of this image. And let's close this. Yes. And let's compare these two one last time. So we do before. There's a little bit of a gradient. Maybe it's a little better. I mean, it's arguably now I can see something there, but you know, whatever. I'm going to say that's probably a good compromise. But that is how I would go about taking care of it. You got to keep in mind, however, that I won't be displaying the image at this level to show features that are this faint. I'll be displaying the image in a way that is probably, I'll try to zoom in here. I can. Plus, 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 plus. There we are. You know, probably something along this line or whatever, these lines. And at this level, all that I have to deal with now is that donut, maybe. But the gradient I don't think would be apparent in any form. So let's, there's one other thing I think I want to demonstrate while I'm here. Sorry to drag this on, but I want to demonstrate something else. We have these two processes which take care of the correction. What I like to do is have a single luminance whose history shows all of these adjustments. The way that I used DBE a moment ago is that it was generating a new image each time. But this time when I do it, I'm going to force it to apply over to the same image. So first let's go ahead and rename this thing. So this will be DBE symmetries, and this one will be DBE gradient, residual gradient, but I'll just say gradient. And so we'll do this, but this time I'm going to say to replace the target image, like that. Oh, right, I forget, you can't do that. You've got to hit the check. There we go. There's the background, here's the target image. So I'll close this, yes, redisplay this, and now we'll do the gradient in the same way. Replace target image, go. Close this, yes. And now I have the history of everything in my luminance image, the 2 DBEs that I did with the settings and everything. So that takes care of the luminance, and now we'll have to deal a little bit with the colors to create a color image and then apply DBE to that image in a similar way.